So today's topic is electroscope. What is electroscope? It is a simple device used to detect the presence of a electric charge. It is nothing but it is a simple glass jar in which a knob is fitted, one platinum wire and two gold leaf are attached with this. This is the platinum wire and this is the gold leaf. If we put positive charge over platinum wire and a gold leaf, okay, then if we produce a charge object, okay, if we produce a charge object, we don't know either it is positive or negative. If the gold leaves come closer to each other, then we can deduct that there is a negative charge, and if the gold leaves repel each other, here you say repel each other, then we can say that it is positive. That means we can say we can again go to the theory that like charges repel each other and like charges attract each other. Now the next topic is principle of superposition. Now what is the principle of superposition? Total force acting on a given charge due to the number of charges. I repeat it again. Total force acting on a given charge due to the number of charges is equal to the vector sum of all the forces, which means, for example, if we have multiple charges like q1, q2, q3 and so on, qn, that means the total force we can write ft. Total force is f1 plus f2 plus f3 and so on till fn. For example, suppose this is a q charge q and these are the other charges q1, q2, q3, q4 and qn. Now if we want to find the net force on this charge, then what we do, this is r1, this is r2, r3, r4 and r1. These are the position vector. Then to find the total force or to find the force between the two charges, we use formula which we have studied in class 11 in our triangle law of vector addition. F is equals to root of f1 square plus f2 square plus 2 f1 f2 cos theta. Now our next topic is beta. It is electric field. We have two type of charges, positive charge and negative charge. What is it? Positive charge and negative charge. The area around the charge up to which the influence of that charge is observed, either it is positive or negative, is known as electric field, and the force experienced by the per unit charge placed at a particular point is known as electric field intensity. It is represented by capital E. I repeat it again. The force experienced by per unit charge placed at a particular point. We have a formula E vector is equals to F vector upon Q naught, where Q naught is a very small charge, or we can say it is a point charge. I'm giving you one logic, that is for a positive charge or for a negative charge. This is 2-point charges where electric field intensity is towards right side and electric field intensity is towards left sides of a charge conductor. Its unit is force, Newton, charge, coulomb. That means volt upon either Newton per coulomb or volt upon meter or joule per coulomb into meter. This is the SI unit. If we want to convert it in CGS, this is dyne stat coulomb. What is it? Dyne stat coulomb. If we want to write its dimension, then the dimension of E vector is equals to m1 l1 t minus 3 and a minus 1. Now the next topic is the superposition of electric field. The resultant force, that was E, at the resultant force on electric field, the resultant force at electric field at any point is equal to the vector sum of all the electric field intensities at that point. Same like a force, that is we have discussed F total is equals to F1 plus F2 plus F3. In the same way, E total is equals to E1 plus E2 plus E3, and we using the same formula, E is equals to root of E1 plus E2 plus E1 square plus E2 square plus 2 E1 E2 cos theta. Now our next topic is continuous distribution of charge. The charge distribution over a length, over a surface or a volume of an object is known as continuous distribution of charge. What is continuous distribution? Charge per unit. I have draw a table, charge per unit. That means charge per unit length, charge per unit area, or charge per unit volume. Charge per unit length is known as linear charge distribution. Charge per unit area is known as surface or areal charge distribution. Charge per unit volume is known as volume charge distribution. The linear charge distribution is represented by lambda, surface charge distribution is represented by sigma, and volume charge distribution is represented by rho. If we want to write the formulas, then lambda is equals to, what is lambda? Linear charge distribution. Lambda is equals to Q upon L, sigma is equals to Q by A, and rho is equals to Q upon V. These are the units. Q coulomb length meter inverse, Q coulomb area meter square inverse, Q coulomb and volume meter cube inverse. Now we want to discuss the properties of electric field lines. Suppose we have two charges, plus and minus. The electric field lines are always electric field line always originate from positive and terminates towards negative. This is the first line, originate from positive and terminate to negative. Second, originate or terminate of charge is proportional to the magnitude of charge. This means it depends how many lines originate or how many electric field lines terminate. It only depends the value of the charge. That means charge is either a small charge having small electric field lines, bigger charge have bigger electric field lines. The third property is these electric field lines do not overlap on each other. These electric field lines do not intersect with each other. Near the charge, electric field is very strong, and away from the electric field away from the charge, electric field is weak. Here the electric field is very strong, and away from the charge, here at these points electric field is very weak.